You'll have to bear with me a little bit. I'm using a different kind of presentation software today. It's a piece of mind mapping software. I don't want it to be a distraction. If it does become one, I will certainly shut it off in this talk. Today we're going to be talking about the Amazon Computing Cloud. And by way of my own self-introduction, I'm Dan Nagy, most of you know, with the Legal Information Institute out of Cornell University. And I actually had a quote from William Gibson in here earlier, who was one of my favorite authors, but then I saw this one today and I swapped it out. What you need to invent is a whole lot of imagination and a pile of junk. And that kind of describes almost the way I think about the Amazon Computing Cloud. We are continually faced with a series of great opportunities presented insoluble problems. At the place where I work at LII, we constantly have a lot of things that are presented to us that we would absolutely love to do. And at some point, it might have even been doing my performance evaluation, or it could have been during lunch. Tom said to me that what hell looked like for him was watching people do what we could have done for 10 years, but we just didn't have the resources to do it. So we started looking around, or I started looking around for ways that I would not shortchange the organization. And I started looking for tools to do this with. And one of the ones that actually Tom brought to my attention was the EC2. That stands for, it's actually ECC, but Amazon got cute, so it's now just EC2. That's the Elastic Computing Cloud. I will constantly refer to it as the Electric Computing Cloud because that's the way I taught it to myself in this one. And the way I think about it is there was a tool out there, it still is out there, called Netcat, and it was often called the network Swiss Army knife. And this is kind of like the infrastructure Swiss Army knife, except with Netcat they just tell you to read the man page, and there's a lot more documentation available out there for the Amazon cloud. It has several different potentials, and it can provide a variety of things to you as far as what you might need an extra server or some extra resources for. It's definitely low cost, certainly flexible, and I put the word outsourced with high degree of freedom because if you were ever trying to sell this stuff to management or people who don't necessarily use tech speak, they will understand the word outsourced. So I figured if you want to work with middle management, we should speak their language instead of making us speak Congress. Let's see where it is. Where's one? Taxonomy and mechanics. What EC2 is there is it's called the Elastic Computing Cloud. It's not a new notion. It has been called utility computing for a couple of years. And the way Amazon has implemented it is basically as a Zen virtualized environment. And what Zen is it's a way that the Linux folks these days are doing virtualized machines. If you guys have used Parallels or any other kind of virtualized desktop machine, it's really pretty much the same thing. And it usually comes stock on some of the newer versions that are out there these days, distributions of Linux. It just came out in, let me see now, Red Hat Enterprise 4 had it as a guest operating system. Red Hat Enterprise 5 has it as you can actually use it as a full-blown Zen server. Both Zen and the EC2 uses Linux or Linux X virtual servers, or anything that really looks like it. Almost any server that has kernel support for Zen, you can use in the Elastic Computing Cloud. You can actually use Windows in the Elastic Computing Cloud. I didn't go there because I have a high office and I didn't want to hurt myself when I jumped. But you can use it. Apparently there's something called, I don't want to pronounce it, QEMU, which is a process emulator. And the note I saw at the very top of a very long white paper was some assembly required. That's as far as I went. The EC2 Cloud allows you to have, hope you guys can read. Public or private images are available. A bit of nomenclature. The images are actually called Amazon Machine Images, or AMIs. You also get when you sign up for Amazon or the Amazon Web Services, you get the command line tools. So you got to start to love the command line if you don't already. You get a set of command line tools for your Windows or Unix environment. The AMIs are run and manipulated from a command line, although once they're running, you can then get into and manipulate them as you would any other Linux installation. A running AMI, that you put into production, is called an instance. And once an instance is running, you can interact with it normally as you would any other Linux server via command line. There are likely ways to tie your GUI into it. I don't use GUI, so I didn't go there, but it's very likely you'll be able to do that if you're not terribly comfortable with the command line environment. The IP address and host name that you get are assigned by Amazon at the time. There is an internal IP address and there's an external IP address, and you also get a randomly assigned Amazon host name. Every time you start the server, that will change, or the IP address will change. You can actually make it so that you assign it or a persistent IP address. Once you do that, you begin to become charged for the IP address. So if you're just prototyping something, it doesn't really make sense to do that. If this is going to be a production server, you would want to actually go ahead and assign it an IP address so you can get back to it. Private images are possible to make and store. Any public image that you modify becomes a private image when you save it, and it will be assigned its own AMI. To make the images, if you can, and there are other places other than Amazon to get AMI images. There are several houses that make them, or organizations that make them, and make them available to you. And when you finally change one, if you were to add or subtract something from it, you need to remake the image again. It's a lot like updating, if anybody's ever made a Knoppix distro. It's a lot like working with Knoppix. Every time you change something, you have to go ahead and go through a little procedure where you then save it back to an image so that you don't lose your installation of MySQL or Apache or whatever you've done. So anytime you change any of the software on the machine, you have to actually resave the image. The storage for this, there are two-way storages provided. Depending on the instance you get, you will get a certain amount of storage with an AMI. Amazon has the Starbucks-esque way of letting you choose images. You can get the equivalent of a small, and then they jump right up to large or extra large. There's really no medium. For what I'm doing right now, I've chosen quite a small image. Storage is provided by the Amazon Simple Storage Server, which is S3. That's what S3 stands for. And that's where the AMIs are stored. The other thing you can store on the AMIs is persistent data that you want for your running instance. Data stored on an instance, on a specific instance, is only there for as long as the instance is on. If you start and stop the instance crashes, and it's possible to crash an instance, that data goes away. So you'll lose log files, you'll lose any web changes. If you're working on a web page or Drupal, you'll lose all that. You can, and this is relatively new, you can take a chunk of your S3 storage, and it's considered to be a raw data format, and you can format it for whatever format your particular instance uses, and then you can use that as persistent storage. Anything you write to S3 is then considered persistent. So if you're going to want to figure out why your instance crashed, write your log files out to S3. It is slightly, in my experience, it is slightly slower than writing to the data that come in with the chunk of storage that you get with the AMI itself.
Question?
Yeah.
What's large and extra large in terms of just sort of orders of magnitude? I mean, petabytes, terabytes, exabytes?
No, you're not talking petabytes. You're always talking terabytes.
Terabytes?
Yeah.
Oh,
And I think the biggest you can get, you start with a 160 gig instance. That's the small. And I think the large, right? And I think the large, it's in the magnitude of a couple of terabytes.
okay.
So, but you can always buy more.
So if you want 100 terabytes, they'll take happily.
They'll sell you the S3 storage. They won't necessarily sell you the storage, because there's a certain amount of storage that comes with the instance itself, and then there's the S3 storage. So you can always buy more S3 storage. They'll have to sell more S3 storage. So, it has an elastic IP address as well, as I mentioned before. So if you dismiss the image, if you dismiss the instance without giving it a persistence IP, you won't get the IP back, or there's a chance you'll get it back, but it's not good. You can allocate a static IP address to it. Once you do that, then that IP address will remain yours for as long as you want it. They'll also bill you a little bit for it. It's not very much, but you do get billed for it. So you can, if you're just, like I said, just prototyping, get rid of it. And then there's also a non-routable internal IP address associated with your instance that is only routable from within the Amazon cloud. So it's a little better for security. So you can have another an organization you're doing something with that has a MySQL server. You would have a MySQL server. The two can communicate only within the cloud. Nobody can get to that stuff from outside the cloud. People within the cloud can see it, but people from without cannot. The organizational dividends, it's you can run one-to-many servers. When you sign up for your EC2 account, you get up to, I think it's 3 servers. And that's fine, you can do it all online. If you want more than 3 servers, you just call them, and they'll work something out with you to get you more than 3. And I don't know what the top limit is. I guess whatever your credit is good for. It's on demand. You only run it when you need it. You can always you can shut it off if you're not going to use it. And it makes it a cheap buy-in to the virtual server environment. So there's always a cost associated that I have found to running my own Zen virtual server. I don't currently have any box that's big enough that I can just call my Zen server. The Zen, they recommend that you have at least 1 gig of memory for your Zen server. So if you bought a box that had 4 gigs in it, your host operating system needs at least 1 gig. I would strongly recommend more. And then your guest operating system requires at least 1 gig of memory. So if you don't have a machine that's readily expandable, this makes a decent way to buy into a virtualized server environment. It's near as I can figure, one of the things we were talking about using before was student projects. They can come in, screw with something, absolutely mess it up. You can blow it away and get it back again. If they have data they need preserved, you can preserve it on the S3 cloud. If they mess up the OS itself, rather than tinkering with it for a day and you have to figure out what they do with it, you just blow it away and get it right back off the image, because you can save it to the image. And we're possibly also, we may try to use it for a release engineer environment. And then I put the internization nomenclature there just because that was what Rob Curley talked about last year, and I figured this was a good place for any interns you might have to play. It gives you wide latitude over single-use or prototype projects. So if you have something that you're trying to show to your dean or your management or whomever, and you're trying to get a new mail server or some kind of networked student printing solution going, you can potentially prototype it on this and show it to them. And if you're trying to show a lot of different products, you can get rid of it pretty quick. Or if you got single-use, single shots, you got a guest that has come in, needs some storage, needs some extra compute cycles for something he's doing, you can just have the server available for him for the amount of time that he's visiting with you and get rid of it. It's like I just said, it was a cheap way to present things to management. And one of the things that I was thinking about was that it is also almost an instantaneous way to provide extra compute power if you ever have spikes in usage. I don't know how many people this would apply to. It certainly applies to us to a degree in that when we get if the Supreme Court decision gets handed down and we get a spike in our system, what we may do is wire it into our, we have a Linux virtual server cluster. So it might wind up being that I also have a cluster node that sits out in the Amazon Compute Cloud that has a VPN back into my in-house stuff. so that if I ever do get a spike where I feel I need extra compute power, I can crank up the node on Amazon, and if I don't need it, it just sits there not costing me a whole lot except for storage. Infrastructure integration. Several ways to get this into your organization. Like I said, it's a Unix environment, so if you don't understand Apache, and I don't understand Windows, it could be a challenge to get in. However, you can use some basic Apache tricks just as redirects. So if you have something on your web page that you need to use your computing cloud for, you can simply use redirects or rewrites to get it there. You can use secure communication for backend operation if you needed it to be a MySQL server. There are ways you can encrypt MySQL sessions back and forth to it, so that you can have your MySQL server sitting out in the cloud, or you can have it reverse. You can have a MySQL server sitting in your room, and whatever is using that data out in the cloud. You can combine it with virtual private network, and or use some DNS trickery if you have that much access to your, if you have that kind of control. If you have that much control over your DNS server, so you might be able to look like you go to an internal host name and it just forwards it right out to your cloud instance. Security. Put on my tinfoil hat sometimes. There's no discernible network perimeter. It all sits in the cloud. I've not been able to determine, nor can I tell, that there is actually any network perimeter defense protecting you from any bad guys out there. Like I mentioned before, it does have an internal routed address that makes it a little bit more to collaborate with others inside the cloud. Authentication is done by certificates. When you first go ahead and install the EC2 environment, one of the things you have to do, you have to generate a set of certificates, both for yourself and for the cloud itself. So anytime you go ahead and log into the cloud, or to even manipulate your instances in the cloud to any great degree, you have to always give it a certificate. It doesn't use any static. It doesn't use static passwords. Once you get into your instance, you can assign it. You can make an SSH server take password. But for the stock instance, you're always going to come in using these certificates back and forth. The obvious and there's the security principles that apply. This is all going to be host-based security for you, for whoever installs one of these. So you're going to need to do all the obvious things, keep everything up as patched as possible. Make sure that if you do generate an image, you've generated securely, that it's as locked down as it can be, so you don't have to go back and mess with it. And also that you encrypt as much of the communication as you can, both in and out of the cloud. Having said that, Amazon has a lot to take care of on this as well, since you can actually shut down instances from a command line. So you don't actually have to be in an instance to terminate it, restart it, stop or start it. They have a lot, and it's role-based security. So you are assigned via your certificate the ability to stop and start your servers. If somehow that gets compromised, there would be oceans of people that could absolutely terrorize the Amazon cloud, the ability to shut down large sections of it. So they bear a lot of responsibility in making sure that those certificates are well maintained and nobody can manipulate any instances outside of their authority. And we should always, as usual, apply the defense in depth model to whatever AMI we build, and make sure that we have layers of security built in and not just one single certificate. What's next? Well, for us, one of the things that we're going to try to use it for is to do some outside collaboration with some folks. And both stuff we have pending and maybe stuff in the future. It makes it a lot easier for us if we can have an instance that, or we can have a server that we can instantly create at relatively low cost and then dissipate when we don't need it. I mean, there's always some kind of vaporware project you're working on which you wish you had another server for, and this is a way that we may be able to provide ourselves with that. We're going to virtualize an LBS cluster node, or at least I hope we are, and that'll give me a little extra both backup and redundancy, that is, and it'll give me a little bit of extra, give us a little extra compute power when we actually need it. And it also, we may use it for developer playground. If we have guys who are learning a new language, and they're programs learning a new language, they're trying anything that they don't really want to do on a shared development box, we can make them their own server that they can play in, rec all they want, and then we can just regenerate it as we need to. And that way, it gives them a little bit more leeway. A lot of them do development on their own boxes now, their own home boxes. So we don't really get to see a lot of what they're working on. They're good about committing it to a repository. And it also gives us a reduction in monoculture. I mean, when I started thinking about this, we have monoculture because we use almost all exclusively Linux and open source stuff. But we also have a monoculture because almost everything we own, except for our backups, exists within our server room. It would be nice if we had something that existed outside the server room. And when Katrina hit a while back, everybody was talking, oh, we're going to swap boxes, we're going to do a colo. This makes it really easy to do a co-located server somewhere off-site. So if you had something that occurred on-site, then you absolutely, and it didn't have to be, and you don't have to run the instance all the time to get that benefit. You can just fire it up once a day, sync to it, and then shut it down, and it just sits there, and it just costs you a little bit to keep it running as far as storage goes. That ends the slide part of it. The one thing I didn't mention, and that everybody's going to ask is, well, what's the tab? The tab is pretty minimal. I didn't want to reprint the Amazon fee schedule because you can all go look at that. What it means for us is if I use the smallest server I possibly can with an elastic static storage, and even if I push 10 gigs a month back and forth across the wire to it, it's only going to cost me, with a static IP address, it's only going to cost the organization $368, which is, if you take that over a series of years, or it may not be as good a value as buying your own server, but they're always going to keep their stuff updated. I can show you guys command line stuff. It's not terribly interesting. I can show you how to look at what instances are running, I can show you how to connect to them, but again, that's all just command line and not terribly attractive. So unless you really want me to, I will. Does anybody have any questions so far? Yeah.
I walked in 5 minutes late, so I apologize if you covered this, but how does processing power scale up? How does that work?
How does it? Well, you can just get it. You go into your Amazon account and you just tell them you want a larger server, and then you can just run the instance you already have on your larger server.
And what does the larger server mean? I want 2 CPUs. I want 3 CPUs.
The smallest one you get, the absolute smallest, is 4 CPUs. I think the most you can get is 16.
Okay, and then they just have a model for paying for that.
Yes. And then you get the storage associated along with that. The only thing that they currently don't do is there's no 64-bit architecture involved in the whole Amazon solution.
I believe there is now for the larger instances.
Oh, is
but
there?
There isn't an option for it for the basic one.
I got it. Okay. And so I even heard thinking about it today with when John mentioned that CALI might want to host a simple server. It'd be easy enough to put one of these out in the cloud. I realized I didn't talk very long. Does anybody have any more questions?
You or anybody else in the room using the cloud in production yet?
Not yet. This was something that I just started doing since April.
Mm-hmm.
So I haven't been doing it in production, although I have stress tested it, and it seems to hold up pretty well. The only overhead I'm actually getting from it right now is when I use VPNs to connect to it, because they're doing encryption on the wire, which it's not desirable. So I'm trying to clear text. I'm just trying to do a clear text VPN back and forth, as long as I get my credentials encrypted down.
So, at our school we try to do firewalling on the box, and we try to run everything behind a firewall, and we have policies that, like you say, are deep. They duplicate each other. How do you get around the fact that you don't have that?
Well, you can put a firewall on your instance. You can do
on your instance. Can you create an instance that is a firewall for all your other instances?
Can
You know what I
create
mean?
an instance? Yes, but then you have to route using the, then you have to get around, you either
Internal routing
have to
only.
give specific routes
And-
or NAT them, but you should. There's no reason why you can't. It's really just like having a natted, you know, like
An added box.
a dual home box.
So I could put all my natted boxes behind one more virtual box that has a public address that I then
Right, you can.
I treat as my firewall.
Yeah, and then, or you can turn the public address off, or you can firewall the heck out of it. But it's all host-based security. There really is no, they don't make any, there's no facility for network-based security on it. They don't do perimeter security. Everybody's been trying to move away from perimeter security anyway, so. Yeah.
That was an interesting comment, Dan.
Well,
Everybody's trying to move away from perimeter-based security.
because I guess it's becoming a little less effective. I mean, you know, everybody. I assume most people in the room work in a. I don't want to get too much of that, but everybody works in the educational, which is usually it's not a default deny policy on the
Right.
on the organization firewall anyway.
Right.
So, but they found this relatively ineffective. I mean, even if you have the absolutely best network intrusion response systems you can possibly have, it's usually closing the bar after the portion is already gone.
I mean, I totally agree with you, but there's this whole group of people.
Yeah, I know.
There's the people who run the tipping point boxes that are always crashing.
Right, yeah. No. Well, that's why you can move your stuff over to the cloud. Pay for it with your P card and they'll never know it's gone.
All right, I'll love the grenade. So I assume that this is the future. How far into the future will this take over everything? Meaning that none of us will have local boxes anymore. 5 years, 10 years, 1 year?
Oh, so I should predict. I don't know that we'll ever not have a box sitting in an organization somewhere. And about, pardon me?
Why would you?
Well, if you just needed some local control or something, I mean, it gives you a great deal of control. But if something goes wrong, you actually need to lay hands on it before you may want to. It also, you lose some control when it's in the Amazon cloud. It's a lot like when people try to make the jump to using Google for their mail. We really don't know what the ramifications are yet for privacy with it. And I looked pretty closely. I want to make sure nobody was snooping on the instances I had running. So I set up some stuff, and I didn't really notice anybody snooping into it. But then, they have access to it at a very low level. I mean, it's just a Zen bot. So if we can get around that, probably in about 3 to 5 years, we'll start seeing a whole lot less stuff in a server room. But there's other ways to do this as well. I mean, this makes real sense for a small organization. If we're already in an organization that has its own virtualized setup that they're trying to get you to buy into, it might be more cost effective to do that rather than moving stuff over the cloud. What this gives you is a little bit of, if you're in a small division within a large organization, it gives you a little more freedom. You can really do what you want rather than having to go through the boards and central. And I'm not trying to do end runs around them.
We're a good example of somebody who's going to dance back and forth on the question, though, John, because it's much less easy than we would like for us to separate our development and production environments. I mean, we should be a lot cleaner in that respect than we really are. I'm slightly embarrassed to admit it, but it's very hard for us to say of any given box at the moment, this is strictly a production box and there's never any development activity going on. If we had an absolutely clean break there, sure, we could say, oh, well, let's commit all that stuff out to Amazon tomorrow. Let's commit all the production stuff out to Amazon tomorrow and let them worry about the infrastructure.
But one of the reasons that we don't have that clean break is because we really don't have enough we really don't have enough compute power to do what we need to do. So we constantly keep cannibalizing some of our non-production servers to do production-oriented stuff.
What about physical location of the virtual servers? Did they give any information on that?
I did. I looked at if I tag my instance, it was in the middle of Indiana or something.
So do you have any control over where the next instance comes from?
No, right now Amazon, it's going to become regional. So you'll have different regions based on where you're located at. Right now Amazon just has one region, and apparently it's somewhere in India. But again, it's I imagine they have a couple of data centers associated with that. So I mean, I've only tagged it a couple times just to see where it's at.
For me, one of the intriguing things is not so much what Dan was saying, and sort of dealing with capacity problems reactively, but the fact that we do have very predictable capacity spikes that go way outside our normal running level, particularly in June when the Supreme Court is handing down the heavy-duty decisions. I imagine, John, you run into a similar thing with lesson runs.
December and May.
Yeah, and the idea of being able to blow the dust off something and putting it online once a year for a month or so, eating the bandwidth charges, is much more appealing than trying to run up another box or maintain another.
And it's a little easier for us because we already maintain a cluster. So I'm already synchronizing data to the nodes of the cluster. It really wouldn't take that much engineering to synchronize the data to the node out in the cloud, only momentarily, and then shut the node back down.
Well, is there also a disaster recovery or at least a reliability issue here?
Sure.
You law schools who flooded recently or ever,
Yeah,
New Orleans,
of course. Well, that
Florida, so on?
yeah, and that happened after Katrina. We all talked about swapping boxes and doing colos. And
Yeah, but no, that's a silly idea.
now,
This one.
and then 3 years later, it's been 2 years later. But yeah, I mean, I invite you guys to try it. I've only been doing it for a couple of months now, and I'm still learning it. The nomenclature may be the hardest thing to learn. Running things, your instances, the AMIs or the images. But once you get that down, and if you're at all familiar with Linux, it really is relatively seamless. I mean, a terminal is a terminal is a terminal. Once you're into the box, it all looks the same, especially if you're familiar with it. So, does anybody else have it? Yeah.
I wasn't taking good enough notes. That dollar amount you gave, 368 for
$368,
the
yeah.
minimum, was that monthly?
Monthly, per month, yeah. And that's, like I said, that's for, I did that with a small compute footprint, but a large network transfer footprint. So, because that's pretty much, we're not really doing anything that compute intensive. All the compute intensive stuff that we have a factory box. Back in well, it's sitting on no, it's actually in server. And that does all the factory stuff we do. So it could get expensive if you were transferring. We a little over a year ago, we started offering US code stuff in PDF format. I don't know that unless we might have to mark that stuff up a little bit more than we currently do to make it work, to store all that, because it's a chunk of storage. And whenever you download one, it can be a huge chunk of data. So I don't know that I would use that in this instance to hold huge corpuses of relatively active data. It may not be cost effective at that point. We're not getting a bandwidth tax anymore at Cornell, so it's cheaper for us to run that stuff in house. But they do make it if you are into the e-commerce, and I didn't go there that long, but that you can wire this into Amazon's e-commerce stuff as well. So and sell stuff over your
Well, going to too cheap to meter? Not too cheap to meter, but the price is going down.
Oh sure, yeah.
And I know there's competition. It's just not.
No.
There are other
Utility computing. Sure.
firms, right, that sell
Sure.
similar services.
Sure. Yeah. I mean, when I would prototype when I was prototyping instances for an entire night's worth of work, I would check the account the next day, and it cost me 22 cents. And that's me pushing, big packages to it and data to it and stress testing it.
That's too cheap to meter.
Yeah.
I think too, this is not so much a problem for us, although it could easily be. If you're operating as you guys once were at Chicago County on very restricted bandwidth, being able to put something out where it's easier for people to get at it can certainly do a lot for response times and download speeds and other sort of customer satisfaction.
Especially if you have a lot of control over your DNS, because then you never get any tracked. I mean, then you don't even get any egress traffic. It looks it up in the top level domain.
A few years ago, we tried to run our own cluster for a student email and run a clustered file system that they talk to, and that's where our expertise petered out. We just couldn't get the clustered file system to work.
Right.
What about this? Is there any help here with that?
The clustering file system. This is pretty much roll your own kind of stuff.
Okay.
The clustering file system, and I haven't looked into a clustering file system yet, where that might come in is if you have an instance that can handle a clustering file system. The S3 images are simply just raw. You consider those raw format. You can format those however you want. So it might be a bit more. It might be a bit easier to get it running here than it was, somewhere else you had it. And you also have the built-in benefit of already having two interfaces. You have the outside interface and the inside interface. So you can run anything you want on the inside interface. You don't have to do a whole. Somebody's stretching. Okay, I don't know how long or short I went. It's not too bad for me. Do we have anything else? That's it? Yeah.
Can you mount S3 on more than one of these servers at the same time, like in the clustering type of thing?
Can you do what?
Can you mount the same file system, like S3?
You don't have to try it?
You haven't tried it?
I would imagine that you could. I don't see any reason why you couldn't. I don't know what happens if you run into read-write conflicts.
Right. No, I'm saying, or do you have to like set up something like a file server type of thing?
Yeah, I don't know that I would actually, I don't know that I would get a benefit from doing that. Maybe if you just read from one, you know, one row, you took one from it. Or one had read write and one had read only,
Right.
that would be a little safer, actually. So if you have real hardware.
That was the problem we ran into with email, an email system. You're reading and writing all the time back and forth to the email system, and in a clustered environment, you know, we would have had to spend tens of thousands and bring in Red Hat to help us set it up, basically, because we just didn't have the expertise.
Well, the problem with the clustered environment is that it doesn't by default keep state.
Right.
So in order to get it to
Right.
work, you have to add in an extra level of state keeping to it.
And that's what a cluster file system offers, is one machine keeps track of the state of which nodes of the cluster are open,
Right.
Opening what files.
Right. So, and typically what you would have, just talking about network traffic, you would have one part of you would have the top level controller of the cluster. You would see and this is just network traffic, and to keep state, you would see a connection come in and remember which node that connection went to. Because if you're talking about IMAP, it would authenticate you to that node, not necessarily the other one.
And in a funny way, Bill, that's part of what's pushing us in this direction, right? I mean, the cluster setup we're running now is great for web serving because we're really doing reads off the cluster machines, and that's about it.
Yeah.
The minute you start running something like Drupal, where it's impossible to tell it to shut up with respect to the file system, you start thinking then in terms of running multiple redundant instances.
Yeah. And that's where we start getting, that's what we got into starting to cannibalize part of infrastructure for production. So our biggest challenge is going to come where I try to make it look seamless, because I don't really have all that much control over my DNS. And I know if I go to the DNS gods and I ask them if I can map one of my host names to an external IP, they're going to want to know why. And I don't really have an answer yet. Yeah.
What access do you have to the virtual machine flat files if you want to back them up? If you don't trust, you know, Amazon's disaster components, that's what
Yeah, no, it's you have access to it. You basically access the file system, and that's you can do an SSH into it, and what you get, anything you can do on a
copy.
Sure. Yeah. Yeah. You could if you wanted to expend the bandwidth, you could run your Tivoli software on the instance and have it back up to whatever you got on site or whatever that's kind of. But you can do whatever you need to do. You can back it up to the S3 cloud, which is pretty darn fast actually. I did some marching back and forth, but you can just drag the data wherever you want. And then it's just a limit of. I don't think you're going to run into a limit of compute. You're going to run into the pipe is going to be. Anyway, usually the staff meeting is the good part. Questions? Okay, well, thanks very much.